Okay. So yeah, most of your answers are correct. So what you do is you have to add one and subtract one, isn't it? To make it as a this way. So if you this one you can take as a according to a minus b whole ten squared x minus 1, isn't it? Sorry. X. Give me a second. Why I'm okay. X minus 1 whole ten squared. So I can take this minus 1 to this side. So this will be y squared is equal to 1. Okay. Okay. Now we got our circle form. So this is our circle equations. But we have seen in our method, we have to take these curves in terms of parametric equations. So you have to change this using the parametric equations. Okay. So let's begin that one. Yeah. So the parametric equations of this system. So what do you think? The parametric form for the circle, for spherical and cylindrical and things we have seen in our vector calculus. Similarly, what will be the parametric form of the circle? Anyone know these things? You may studied in the vector algebra or something. So where's the others? Only 46 people are here. So see here, this is kind of like, what is the trigonometry of sine square theta plus cos square theta is equal to 1. So in that sense, okay. So if it is 1 and then you can take excess, let's say to get this one. Okay, so like that you can equate this one. Okay, so if I say, for example, okay, let's take x minus 1 as in this equation, let's take as cos theta. Okay, and y as a sin theta. So if it is you have something, let's say x minus a whole ten squared plus y minus b whole ten squared is equal to r squared as a circle, you will have x equal to I think. So let's take so r cos theta, r sin theta, I guess. I think you don't need, if it is going through the origin, we will have this equation x square plus y square is equal to r square. The x should be r cos theta and y should be r sin theta. See, the LHS part will be r squared cos square theta plus r square sin square theta. R squared cos square theta plus r square sin square theta. So if you take r squared common, this will be cos square theta plus sin square theta will be 1. So RHS equal to LHS. Okay, so LHS equal to RHS. So that thing, so in here because of 1, our R will be 1. Okay, so therefore we are taking, let's take cos t. So we don't need to change the parametric one. So as I said in the method, let's take t. Okay, no need to take theta. So what will be the x now? If it is x minus 1 is cos theta, x will be, this minus will be go this side. So 1 plus cos theta. Okay, cos t. Similarly, y itself sin t. And z will be given, no? That will be 0. That is equal to 0. Okay. So these are our parametric equations. Okay. They didn't give in the parametric way. They have given the equation curve. So we are changing. Okay. Okay, I will continue. So you can see, yeah. So we have found x equal to 1 minus cos t, as well as y is equal to sine t, and z is equal to 0. Okay. Now we have two equations. No? One is C1, which is x squared minus 3x minus z2 square plus 6z is equal to C1. This is our equation number 1. Again, our second one, x plus y squared minus 2z is equal to C2. These two are our general equations, C1 and C2. Okay. Now, substitute. Okay, substitute in 1 and 2. What are you going to substitute? This one. Okay. Substitute this in the equation number 1 and 2. So, first, if you substitute in the first equation, you will get, so 1 minus cos t. Is that 1 minus or 1 plus? 1 plus, no? So, yeah, 1 plus. So, 1 plus cos t. Sorry, I'm taking theta always. Okay. 1 plus cos t whole thing squared minus 3 times 1 plus cos t. Again, z is equal to 0. Okay, again 0 is equal to C1. So if you, can you simplify this one and find the answer for C1? What will be the C1 in terms of the parametric equation? Can you simplify and let me know? So this is like just a plus b whole thing squared, no? So what is a plus b whole thing squared? This will be a squared plus 2ab plus b squared. Okay. So just simplify this one. Thus you can see the method. It says after you find pi and chi, okay, C1 and C2, we eliminate single parameter t from the equation number 3 and get a new relations involving C1 and C2. So that is what the process now. Okay, we are going to find the new relations of C1 and C2. Okay, after that we will replace the C1 and C2 in the and 2 and require the integral surface. Okay, so what is the answer? Okay, I'll get some answer. Let me see. Uh, Cos squared. Yeah, okay, good. Yeah, fine. So this will be cos squared t and minus cos t plus minus 2. So this is our C1. Let's say this is our equation. And from 2, can you find the relation using this parametric? Can you find another one? What is C2? Just substitute in this equation. Okay. And give me one. Okay, let me see the answers. Okay. Okay, can you go? Yeah, you are getting something. Yes, 1 plus cos theta plus sin square theta. Can you go through some more steps to find some, relation between C1 and C2? How you can, in this equation, you can't find any, yeah, one of the person got the idea. 142, okay. Yes, 126. Yeah, fine. So you have to get something related to C1. So you do some more simplification. So for the 1 plus sin square theta plus cos square theta will be 1. No? So in that identity, you can use the trigonometric one. Okay. Wherever you get sin square theta, you can substitute 1 minus cos square. So it will be give something like this. Somehow you will get some relations between C1 and C2. Okay. Yes, good. 93 got the answer. But yeah, you have to go. You have to somehow you have to find there is some relations between C1 and C2. So if you do some more simplification, you will get like minus cos square t minus cos t minus 2, something like this. So from this 3 and 4, we can conclude as C1 minus C1 is equal to C2. Therefore, C1 plus C2 will be 0. Okay, this is our relations we have found. Okay, that means function of, if you put C1 comma C2, it will be, sorry, it will be 0. Okay, so no need to this one. Anyway, C1 plus C2 0. This is our relations we have found. Yes, good. So now, shall I continue? Okay, I'll go to the next steps. Okay, so we have come to the conclusions. Okay, from that we're gonna conclude our. They are asking you to find the relations, integral surface. No, so finally we okay. This is our final step. Finally, we replace C1 and C2 with the help of number 2, I mean equation number 2, and obtain the required integral surface. Okay. So we have found something pi is equal to C1 and chi is equal to C2. And then we have find one relation C1 plus C2 is equal to 0. So whatever you find pi, from this relation, you substitute whatever the C1, I mean pi, whatever the chi. Okay. So what is our pi? Pi was 2x square minus 3x minus z square plus 6z, isn't it? Again, C2 will be x plus y square minus 2z, which is equal to 0. Therefore, if you simplify this one, x squared, y squared, again minus z squared minus 3x, there's no y, okay, sorry, this is minus 3z, 3, this is x, no, sorry, sorry, this is minus 3x and plus x, this will be minus 2x, and then 6z minus 2z will be 4z. Okay, so this is our final integral solutions. Okay, so this is how you have to do for the, if they ask you to find the integral surface which is passing through some, curves. So there are some extra notes there, but I'm not gonna take more time on this, but you can check. Okay, so there is a notes for the method to find if, so here they have said it's passing through the curve. Okay, passing through the curve. So this is a method. But what if it's the surface is orthogonal? Okay, surface is orthogonal to the system. Okay, so there is a method. So this is your exercise. You can search in the books or everywhere. Okay. So nothing big thing, just the same process, but there is some extra steps. Okay, so you can check this one. This is your exercise. Surface, so the heading will be surface orthogonal, okay, perpendicular to a given system of surfaces. So you can search like this: surface orthogonal to a given system of surface. So you can search and find the answer and find the examples. Okay. So for this question, I will give you one more one or two example, exercises. So you can try in the same way. Okay. So the exercises are, please write down. First one, um, find the general solution of the equation x minus y of p plus y minus x minus z of q, which is equal to z, and passing through the circle z is equal to 1 and x square plus y square is equal to 1. So this is one of the question. And second question, you can try this one. Find the integral surface. So the question may become like find the integral surface or find the general solution. So everything is same, okay? Of the linear PDE x times y square plus z of p minus y times x square plus z of q, which is equal to x square minus y square z. So you can use any type of type 1, 2, 3, 4 to get the C1 and C2, okay? So that is, you can use that as a reference, okay? Which contains the straight line, okay? Let's say straight line is equal to y0, z is equal to 1, okay? So try these two questions. Okay, let's continue our lectures. So this is coming under the section of linear PDE, okay? First order linear PDE and Lagrange. After that, integral surface has been coming under that, okay? Anyway, so after that we have also studied about. Okay, I think I lost the notes. Okay, so no problem. So we also studied about the nonlinear case, okay? First order nonlinear one. Do we? First order nonlinear. So what is the method we have studied for the first order nonlinear case? Can you remember? Go through the notes and tell me what is the method we have studied. last lecture, last time, last part. So what is the method we have studied for first order non-linear PDE? We have proved derived one method, no? What is the method name? Yes, good. Only one answering. Where's the others? I think that is where I have left, no? Did I finish that question? No, no. So there's an example I have given you, like f is equal to p squared plus q squared of y minus q z is equal to 0. So did I finish this? Yes, good. Yeah, you have found the idea, no? What is the method? Chapitz, okay? Chapitz method. So we have derived the equation for that. So please write down, just write down this as again like a summary, okay? Or otherwise it's okay. I will do this question again. So it's just to remind you, okay? Did I finish this question? Can you check your answers? Did you all get the answer? So what will be the final answer for this one? I think this is the question I gave you. P squared plus q squared of y minus qz is equal to 0. So did you get the final answer? Answer me, please. Only 1, 2, 3 people are answering. Where's the others? There are 50 people here. Where's the others? Only 1 or 2 people only asking. Okay, where is... So I need to call you. Then only I can see. I don't know whether you are in the lecture or not. Okay. 018, can you answer me? Did you get the final answer for this one? Answer. Give me the answer. I think I gave you the answer, but did you find it? 018, can you answer me? Also 039 and 129. 039, 129. All should answer me. Did I answer? Whoever answer me, tell me. Did I get the full answer for this question? Oh, where I have finished. Yes. Wait a minute. So where I have finished this question, or shall we do again? Okay, where is the 018, 039, 129? Are you here? Okay, I will do it again anyway. Okay, but I want these 3 people to answer me quickly. Okay, let's do that. F is equal to, this is a non-linear Chapitz method, okay? Chapitz method, we have the question p square plus q squared of y, okay, minus qz is equal to 0. So we have, what is our Chapitz equations? Chapitz equation we have derived as dx over f of p is equal to dy over f of q is equal to minus dp over fx plus fz of p. This we have derived now, which is equal to minus dq over fy plus fz of q, which is equal to dz over pfp plus qfq. Okay, this is our Chapitz equation. Somehow you have to memorize this. Okay, so find a easy way to memorize this. So okay, so from here you can see f of x will be, there is no x terms, therefore 0. Okay, f of y we got like p square plus q square, and f of p will be 2py. Okay, f of q will be 2qy minus z, since here. Okay, qz. Again, fz we have minus q. Okay, so we have find the parameters. Only we have to substitute in this equation. So let's take this equation as star. Okay, and then okay, so I'll go. I don't need to waste my time here. I'll go quickly. Okay, so dy over tqy minus z. Again, dp over pq. Okay, you can check whether my answers are correct. Okay, so if it is different, you can correct yourself. If it is you're wrong, or correct me if it is my wrong. Okay, so again 2p squared y plus 2q squared y minus z of q. All right. So first of all, let's yeah, according to the method, we are going in the steps. Okay, there's a working rule I have given you. So in that sense, I'm gonna choose dp and dq, these two terms. Okay, so let's consider dp over pq, which is equal to minus dq over p squared. So cross producting, and you can take p and p cancel out, and cross producting you can have p dp is equal to minus q dq. So if you're integrating, you will get, let's say, p squared by 2 plus q squared by 2, which is equal to let's say a by 2. Yeah, so I can take a is the arbitrary constant. Okay, arbitrary constant. Please write down nicely. I'm just writing short. Okay, so a is equal to p squared plus q squared. So this is one of our finding. Therefore, our so our equation, our main equation f will be turned into ay, because we have this one. Our f is, so f is something now. This is given. Take as a equation number 1. So that equation will be changed into ay qz is equal to 0. Okay. So from this, what you can get, what is our q? Q will be ay over z. No, I'm just taking this side and taking ay over z. Okay. Why? Because we're gonna find out some possible relation here. Okay. I'm going in the order, so you can check the order with in our working rule. Okay. Sorry. Okay. So then, so what is our p square plus q square will be a. So I have found some relation for q. So let's take p square plus a square y squared over. So again, our meeting gonna end in 10 minutes. Okay. So all right. So y squared over z square, which is equal to a. Then what is my p squared? This will be a minus a squared y squared over z square. Therefore, p will be, okay, plus or minus square root of a minus a squared y squared divided by z square. Okay, so I have found some relation of p and q. Okay, now our next step will be, we have to find some relation for z, isn't it? So z is equal to, we are taking z is a function of x and y. So of course our total differential will be da bar z over da bar x of dx plus da bar z over da bar y of and dy. Okay. So again, this one we know this is a notation of p dx plus q dy. Okay. So let's substitute this one, this p here and this q here. So we're gonna take only our positive terms, avoiding the negative terms. Okay. So let's take our positive term a minus a squared y squared divided by z squared dx plus again a y over z of dy. Okay, this is q, this is p. Okay, Then if you take the z square as a common fraction, so you can yeah, square root, no, the whole square root. So if you take the square root, it will come like a z squared minus a squared y squared of dx plus this one, this will be z square as a common divider. Then in terms of square root, it will be turned into z, no. So I'm multiplying this side, okay, dz. Again, here also we have z, so no problem. Ay dy, okay. So please check this, simplification. I'm going a little faster because it already done so many things, okay. And then, okay, so we have to take all the, z terms, y terms, x term separately to get our separation, integration, okay. So I'm gonna take, yeah, I'll take the other window, okay. Please write down so far. Okay, so our equations, so for the integration, I'm just taking the terms this side, okay. A z squared minus a squared y squared of dz is equal to dx as it is, and ay divided by, okay, this term. Okay, what I'm doing is I'm dividing by this the coefficient of dx, okay, both sides. So it will be give a yeah, nice integration term, I guess. Okay, so then okay, so then what we are doing is we are these two are seems like same, no. So I'm taking this, these are your choice, okay. These are simplification and the knowledge of integrations, okay. So for this these two are similar one, so I'm taking the same term one side, okay. A z squared minus a squared y squared of dz. Again, if I take this side, it will be minus ay over square root of a squared z squared minus a squared y squared dy, okay. So this is one side. So here you can see we have yeah, so what they are doing is for the integration purpose, okay. So I'm gonna multiply, okay, in the next, you write in the next step, okay, I'll write here. So you divided by 2a and multiply by 2a. So this will be 2a squared and I'm dividing 2a, okay, because of the integration purposes. Then you can see this is a integration of 1 over 2a times d of square root of a z squared minus a squared y squared. Can you check this one? This will be dx, okay. Can you check? So what is this one? Is that correct? So, okay. So these two are common terms now. Since of this, this is a linear function, I can take the common term a z square minus a square y square, and then this will be 2az dz minus 2a squared y dy. Okay. So see the so 2a z squared differential one will be 2az. A squared y squared will be 2a squared y, okay, in terms of y, because I'm taking this with respect to y, this with respect to z. So you will have this one. This is a total differential of this one. Okay, that's what happened. Two a sec minus square y squared Yeah, check around. Okay. So you just do the differential of this one, see whether you are getting this one. Okay. So in that sense. Okay, then so after that you can integrate this one. Okay. So if you integrate this equation, you will get 1 over 2a. Okay, integration of and differential of, we will get the original equation. This will be the itself. Okay, a square by square. This side you can get x plus let's say one arbitrary constant. B is a arbitrary constant. Okay, so check these steps. These steps only the problem. Okay, check whether you are getting, sorry, this and this. These two are the little bit of things you have to take down. So these are coming under the integrations in A level and things. Okay. So then, yeah, when I'm integrating the differential, I'll get the original equation. Then this side x plus b, b is an arbitrary constant. Okay. Now, okay, can you simplify this one? You'll get what? If I simplify this one, a z square minus a squared y square. I take the 2a this side, okay? Cross product 2a this side. And again, square root, take the square both sides. It will give you a z square minus a square y square, which is equal to 4a square. So 2a going this side, so 4a square and x plus b whole thing square. Okay. And then what is from this you derive what is z square. So that is our point, no? So no need to take z as a in square root. Just write in terms of z square. So you will get the answer a times 4 of x plus b whole thing square y square. So I see some people has simplified this also, no problem. Okay, see whether you get the same answer of mine. So this will be the final answer. So you can check the integral and things. So that is about the Chapitz method. So only thing is in the Chapitz method, you have to memorize that equation itself and substitute the things, and you have to learn the integral processes, and that's all. Okay. So you have to get P and Q and then substitute in the z is equal to zx comma y differential equation, the total difference of z. That's all the thing, no? Simplifying that. So I will find some questions, and also you can find some questions as well for the Chapitz method. Okay. Okay. I think our meeting will be end, and again